I'm from the friendly part of America, so I like to get to know my audience a little bit. I've met some of you at some of the functions beforehand, but it would be a big help to me if you could give me your names again, because I have a very bad short-term memory. So on the count of 3, 1, 2, 3. I'm never going to remember that. So I'm Coraline Ada Ehmke, at Coraline Ada on Twitter, and my URL is Where Coraline Codes. As I was introduced, I'm in charge of developer happiness at a company called Instructure. And my team is about refactoring code, culture, and processes. And this talk is about things that I wish the developers who came before me had done differently. So I'm going to break some taboos today. I'm probably going to lose some friends today. But I think it'll be worth it to spark some conversation. What the? They're real. They're totally real. Drop bears. It's real. Not scared at all, though. They look really cuddly. So my talk is entitled Prefactoring, getting it closer to right the first time. But really, we're going to have a serious discussion about the A word. I know. So I've been doing development for about 20 years. And when I started, the only methodology that we had was waterfall. That's just what we had. And we all know that waterfall is terrible, and we don't want to go back to that. It's really hard to add features to a waterfall project. There's a lot of friction around changing a design. You fail last, and it's really hard to fix things. But there was some good stuff about waterfall as well. You had a planned roadmap for where your application was going to go over time. There was good documentation. And there were design artifacts that captured not only what the code was supposed to do, but why. So there was some good stuff in there. And I think that in moving away from waterfall to what I call just-in-time design or just-in-time architecture, the agile process, we've lost some nice things along the way. I think the pendulum may have swung too far in the opposite direction, but we don't have to fall into binary thinking about architecture. It's not architecture astronauts versus cowboy coders. That's a false dichotomy. Big upfront design is not the only alternative, and no design at all is not a viable alternative. So I'd like to explore how we can be thoughtful without over-planning. This is a formal definition of architecture, the composition, design, and interactions of a system. I like to think of it as creating order from chaos. I think of it like a sculptor who sees a block of granite, and within that block of granite, the sculptor can see the statue, see the image that wants to emerge from it. And by applying will and discipline and creativity, they can create this image out of this raw material. Now, the natural tendency of a chunk of granite is to turn into a boulder, which will turn into chunks of rock, which will turn into gravel. In the same way, the natural tendency of our code is to turn into spaghetti, to turn into legacy code that no one wants to touch, to slide into entropy. It requires discipline and will and creativity. Architecture is about managing tension. It's almost Newtonian. When you push on one side, something has to give. Being thoughtful about managing that tension is really, really important, because whether you realize it or not, when we're writing code, we're making compromises. And I'd rather make a compromise consciously up front than discover that I've made an unconscious compromise down the road. Goethe said that music, I don't want to get it wrong, music is liquid architecture, and that architecture is frozen music. Now, music obviously takes a lot of technical skill, but it's not technical skill alone that makes music beautiful. It's collaboration, it's composition, it's the mixture of melody and rhythm and talent and all of these other things. That's what makes it beautiful. And I think our architecture can be beautiful too by applying some of the same sort of metaphors, the same thinking about it. But our architecture today tends to be utilitarian and brutalist, something we tolerate, not something that inspires joy. Deliberate architecture isn't fashionable anymore. But what happens when we disregard architecture altogether? Do we really end up with better software? I'm going to share a case study, a cautionary tale, if you will. The last project I worked on was called Pandometer. It's basically a replacement at my company for Code Climate and Metric Foo. And we did it in several phases. We started out with design comps. So we looked at the charts and graphs that would answer the questions about code quality that we needed answers to. And we spent a lot of time iterating on the design, not only of the charts and graphs, but the kind of data we were going to represent and how the user would interact with it. Our second sprint was on a series of command line analysis tools. So there's Society, which is a really cool gem. I recommend you check it out. that we wrote, and it basically detects and maps out coupling between classes, both afferent and efferent coupling. There's fukuzatsu, which is a non-opinionated measure of code complexity. Churn, count on count, some other tools that we brought in there as well. We had Reek and some other things. Our command line tools were our second phase. Our third phase was something called Panda Pounce. And Panda Pounce was basically a job runner that you could plug metrics tools into, and it would execute them and gather output from them. And the point of that was to like have all these tools that we could just sort of plug in and gather metrics and start charting them over time. So the client side of implementation came next. We actually had two teams, sort of the front end. Well, I don't know. A lot of work was done on the front end. So when it came time to actually start making the front end functional, we had fixture data that we served up through Rails controllers via a JSON API to a JavaScript MVC, which then used D3 for visualizations. All good. The Pandometer API was next. So this was basically a way for all the command line tools data to flow into Panda Pounce and get posted to Pandometer to be stored in a database. In Sprint 6, we decided to tie it all together. It was time. So Panda Pounce generates JSON, goes into the database, and is displayed through Pandometer. And this was sort of the request response cycle that we got. Painfully slow. So what happened? Well, we had queries like this. If you look closely, you can see we're doing a recursive query. And what this query does is find the ancestors to a commit. That's really easy to test, let me tell you. We also had everything stored in a generic measurement model. Let's take a look at what a measurement model looks like. It's raw JSON in the database. I couldn't fit it on one screen, so let's zoom out to 2-point font. That's a record. 202,000 characters of JSON. I look at that, I can't understand it, I can't read it. I'm not parsing that with Ruby, but that's what we were doing. Sprint 7, data model. We should have thought of that, right? We put ourselves in a situation where we had optimized for writes, and a reporting system should be optimized for reads. So I found that profanity and rework go together really well. It's hard to take something apart once it's all been glued together. So we had spent so much time iterating on the front end that we were not attentive to the overall design of the system, and we ended up having to do a lot of rework. So how did we get there? I don't think that the experience of my team is unique. I think we all, to some degree, fail in a similar sort of way. And how does this happen? We do canonical development. We do Rails by the numbers. We're in a hurry to produce an MVP. We build our houses on really shaky foundations, and we spend tons of money on expensive paint. We treat a backlog like a stack. We pop a feature off of it, we implement it, and we never really look down to see what's coming next. And we have lots of hands on the code, and no overarching strategy for how we're actually going to do an implementation. We spend more time optimizing our style sheets than we do our data models. And I'm not saying don't optimize style sheets, but I'm saying we need a balance between front-end work and back-end work. To make things more complex, we're increasingly using JavaScript MVCs. JavaScript MVC frameworks are great because they mean you can get it wrong twice in 2 different places in 2 different languages. Awesome, right? There's been some talk about service-oriented architectures today. There will be more talks about that. SOAs will not save you. If you can't properly construct a data model, what an SOA is going to do for you is to break it into 10 pieces and add latency on top. And you're going to have the same problem in 10 different places. Agile in theory means we can determine the success or failure of an idea quickly. But this theory falls apart when you're working in a large system with a lot of moving parts and people working in independent vertical slices. We work in these small iterations, and we hope that in the end, everything comes together exactly right. Unfortunately, that rarely happens. So why do we do things this way? I think a lot of the development we do is guided by fear. Fear of premature optimization. What's the opposite of premature optimization? In my experience, it's no optimization. If you don't make time for optimization as part of your process, you're not going to get to it later. Gary Bernhardt said, "We'll cross that bridge when it's burning beneath us." Fear of over-designing can lead us not to design at all. Fear of gold plating. Nobody wants to be accused of gold plating, right? But an engineer who focuses on the structural integrity of a bridge, that's not the same as gilding. Focusing on the structural integrity of your application is not gold plating. is planning for extensibility and maintainability. Sandy Matt said that opinions about what good code looks like don't translate into concrete advice. We have lots of patterns for refactoring methods and classes. We don't have a lot of patterns we can follow that are good architectural structures for our object model or for our applications. This one drives me crazy. In every text editor, there is a drop-down menu that says File, New, and we're terrified of it. We'd rather open up an existing class and throw more methods into it than create a new file. It's not like we have to pay extra for more files. It doesn't work that way. And the hardest thing of all, even harder than File New, is to delete a file. We should ask ourselves why that is. I couldn't find a quote to support that point, so I made one up. Our classes want to attract as many methods and dependencies as possible because our classes are very selfish. They want to be important. They all aspire to godhood. It's up to us to tame them, to curate them, and to make them good little organisms in an overall ecosystem of healthy code. That doesn't happen accidentally either. A lot of talks over the last year have been about monoliths and how to fix them and so on. But with just-in-time architecture, our code tends to monoliths. Without planning for a design, you're going to be bolting on features, and you're going to be patching and duct taping, and you're going to increase complexity and coupling, and you are building the monolith of tomorrow. Doc Norton said, he's quoting Steve McConnell, the problem with quick and dirty is that the dirty remains after the quick has been forgotten. We make compromises along the way, and that undermines our overall effort. Fear of missing deadlines. We bring this on ourselves. We assent to deadlines that don't allow us to write the code that we know we want to write. What if we stopped treating deadlines as constraints and instead started treating them as milestones? What would happen to the quality of our code? No time to do it once and do it right. We'll do it twice, wrong both times. That's not the way I want to write code. Imagine building a race car and deciding to focus on the speed of the car at the end of the project if and when it became a problem. Doesn't work, trust me. This is not a star-gone supernova. This is the output from society showing coupling between classes in a mature 4-year-old Rails application. This is where all of our code is going unless we're deliberate about its design. Acronyms, friends or foes. As developers, we love acronyms. Acronyms are fun. They are cognitive shortcuts. They also make us feel safe and distance us from decision-making and reduce the risk of our being wrong. But at what cost? Dry, I think, is one of the most overused acronyms. I've seen developers jump through hoops where they're using yield blocks to prevent having to copy 3 lines of an iterator. So to write a method that they pass things into and start doing conditionals and all this crazy stuff. It's like, readability is the ultimate goal of code. I write code for humans first and machines second. So dry is not about not repeating code. It's about not repeating an idea, not repeating a semantic entity. It's about clarity. Yagni. Yagni is not about managing code. Yagni is about managing yourself. It's a way of avoiding the paradox of infinite choice. We can't predict the future, we say, right? But we also can't afford to pretend that the future is never going to come. There's nothing wrong with being a little prepared. Don't code as if today is the only day that your code is going to be in production. Your code is going to be there long after you're gone. So I want to propose a couple of new acronyms for us. Gemini, just might need it. Leave some doors open on your design. Don't shut them all. Intuition's great, and I use intuition as I code, but I tend to remember the times that I was right and totally forget the times that I was wrong. My other new acronym is YAGKey. You ain't going to get to it. Temporary code is the longest-lived code of all, and if you don't believe me, search your code base for fix me and to do. If refactoring is not baked into your process, if you're not doing it as you're going along, YAGKey. So what can we do to ensure a healthy, extensible architecture without falling into the trap of over-designing? Realize that today's quick fix is tomorrow's legacy code. The word legacy outside of the programming world is a gift from one generation to another. Think about those who are going to come after you. Do what you can to make their lives easier. You don't want to be on the other side of a get blame. Consider the code that you write today as a gift to your future self. And keep the big picture in mind. Fixing a method is really easy. Fixing a design is really hard. We have really well-documented strategies in place for refactoring a method or extracting classes and doing things like that. but we don't have really good patterns for fundamental aspects of our architecture. That means that we have to give ourselves room to fail, create opportunities for experimentation, and create learning opportunities about the fundamental building blocks of our applications. I hear lots of developers say naming things is hard. Naming things is not hard if you know what the object that you're working with is doing, if you know where it fits into the narrative that is your application. It's not naming it that's hard, it's understanding it that's hard. Once you understand what its role is, the name should come really easily. Developers, especially Rails developers, we tend to think tables before we think objects. I think this is a poisonous idea. I want data models that answer questions. I want persistence to be a service to my application, not the central aspect of my application. I think Active Record leaves us down a bad road with every model inheriting from Active Record, basically defining the thing that I am making is a persistence object, when really it's a container for business logic, and persistence is something that I want to happen later. Design your object model based on, not on abstract principles of how you're going to normalize it in a database, but how it's going to be used to answer questions that your users are going to ask through the user interface. This is really, really important. And I think as we spend time designing the front end of our applications, if we make our data models in sync with those front ends, we're going to create a structure that answers questions more easily than if we focus completely on normalization. Recognize that small decisions pile up, and they can have a massive effect. If you're wrong 1,000 times on a small level, or once on a big scale, that 1,000 times being wrong is much, much, much harder to undo than being wrong early and giving yourself a chance to iterate over your design. Collaboration over code reviews. I don't like pull requests. And again, I'm probably losing friends as I say that. By the time code comes up in a pull request, 1,000 micro decisions have been made about how it's going to look and how it's going to function. If you have an alternate idea, maybe even a better idea or a different idea, or questions about why something was designed the way it was, or a suggestion for how to make it better, by the time it comes up to a pull request, you may be reluctant to share that kind of feedback because someone has put a lot of work into that already. You don't want to make them feel bad about the work that they've done. You don't want them to be defensive about the code that they've written. So we end up accepting code that is technically sufficient instead of excellent. Code that doesn't necessarily live up to our architectural vision or our standards of quality, and thus begins to slide into entropy. We need to learn to fail safely, create safe spaces for failure. We need to prepare to be wrong. We need to embrace being wrong. Being wrong is creating learning moments for us. Do it as early as possible, though. Don't wait till the end. That's what happens with waterfall, getting wrong at the end. Getting it right the first time is not a goal of agile development. That's a goal of waterfall development. Don't fall into that same trap. We all know this. We don't say it out loud very much. There is never a refactoring phase. If you don't do your refactoring as you go, yagti. You are never going to have time in the future to fix the duct tape that you're putting on your code today. Architecture is going to be there whether we design for it or not. We can choose to let it happen to us, or we can be deliberate about it. In the old days, we had dedicated architecture teams. It was god-awful. I don't want to go back to that. But we had some control over architecture. Today, it's democratized, which is cool. We're all architects. This is a good thing. This moves us toward being generalists. But with that freedom to create architecture collaboratively and independently, there's also a lot of responsibility that comes with that. We need to all be the best architects that we can possibly be. We owe it to our stakeholders, we owe it to our teams, we owe it to our future selves to be thoughtful. Architecture is just about being thoughtful, applying discipline and will and creativity, finding the sculpture in the block of granite and working to help it emerge. I'm confident that with a little bit of changing, a little change in our thinking, a little change in our processes, being more thoughtful and more deliberate, we can create code that's not only functional and timely, but elegant, beautiful, something we can be proud of. Writing code like that is what makes me happy. Think about what makes you happy. I'm Coraline Ehmke. Thank you very much for your time, and I'm so happy to be here today. Thank you so much.